All right, let's go ahead and start talking about this warm-up. So number one's kind of an interesting problem because I have to make use of the information that they gave me first and figure out what it's showing me. So I see that I have two 40-degree angles here, and I have two 80-degree angles. So let's see what that can tell me. If I have a 40-degree angle here and a 40-degree angle here, those two angles are congruent to each other. And if I were to draw around this angle at the top, that angle would be this segment and this segment put together. The bottom angle has that diagonal as one of its segments, and then across the bottom. What kind of a letter did I just draw over? A Z. When I can draw a Z like that, and these angles tucked into the corners are congruent, what do we call that pair of angles, by the way? Alternate interior angles. So we have congruent, alternate interior angles. What does that mean about the top and the bottom line segments then? They're parallel. So the top is parallel to the bottom. That's what finding this pair of alternate interior angles has shown me. Now I have another pair of congruent angles here. I have this 80 and this 80 up here. So those two angles are congruent to each other. I'm going to trace around this left-hand angle. So that would come down this side right here, and it would follow along the diagonal. And then to trace over the right-hand angle here, I would go across the diagonal and then down the right side. What do we call these two angles again? Alternate interior angles, because I can draw another Z shape, and they are congruent to each other. So I have congruent alternate interior angles. So what would that mean about the left side and the right side of this shape? They are parallel to each other. So the left side is parallel to the right side, and the top is parallel to the bottom. Is this a parallelogram? Yes. Says we have to justify our answer. If I know that the top is congruent, sorry, not congruent, if the top is parallel to the bottom and the left is parallel to the right, that is the definition of a parallelogram. Two pairs of opposite parallel sides is my reason. That is the definition of a parallelogram. All right, number two. What's it showing me in number two? It shows me parallel. That's these little arrowheads. So I have one pair of opposite parallel lines. Is it showing me anything else other than parallel? Look closer. They're congruent. Both the top and the bottom are 12. So the top is congruent to the bottom. So they're parallel and they're congruent. Is that enough to say that this is a parallelogram? Yes. if we have one pair of opposite sides that are both parallel and congruent, then that is enough to say it's a parallelogram. So that would be my reasoning there. Nice work on the warm-up. So make sure you're watching for alternate interior angles. They can definitely come up in all the things that we do where we have parallel lines. We are going to switch gears and go into your notes now, and we're going to finish talking about rhombi and squares today. So we're going to do a couple more examples where we're looking at a rhombus. We're going to look at a couple examples where we're looking at squares. We're going to start off at the bottom of page 7, because we had one more problem at the bottom of page 7 that we needed to look at. All right. I want to look at this shape here, KLMN. They tell me that it's a rhombus. What do we know about the 4 sides of a rhombus? They are congruent. So KL is congruent to LM, is congruent to MN, is congruent to KN. And what do we know about the diagonals of a rhombus? They bisect each other. So that means KP is congruent to MP. And LP is not congruent to either of those, but it is congruent to NP. There's something else I know about those diagonals that's happening right here where those 2 diagonals are crossing each other. 90-degree angles. It's making 4 right angles in there. What do we know about the angles of a rhombus? So I'm looking at these angles here. What do I know about those angles? What do we know about the angles of a rhombus? Which one is congruent to, which one? I'm sorry, just in here. K and M are congruent. Opposite angles are congruent, yes. I noticed that K and M both have this diagonal going through them, right? They share the same diagonal. What is that diagonal doing to angle K and angle M? Bisecting it. So LKP is congruent to NKP, and LPM is congruent to NPM. And then that would mean what about L and N? They're also being bisected. So KLP is congruent to MLP, and KNP is congruent to MNP. All right, so we've got this all marked up just from knowing that this is a rhombus. Let's see what information they gave us to work with. It says that angle LMN is 75 degrees. LMN. So these 2 angles put together is 75 degrees. And they want us to find the measurement of angle KNP. KNP. So we're looking for this angle right here. There's a couple ways I could go about doing this. What do we know about these 2 angles? The one that I have circled there in blue, that whole angle M, and this whole angle right here. They're consecutive. And what do we know about consecutive angles on a parallelogram? They're supplementary. Remember, a rhombus is a special kind of parallelogram. So this would have all the same properties of a parallelogram. So the measurement of angle LMN plus the measurement of angle KNM is equal to 180 degrees. How big was LMN again? 75. So I have 75 degrees plus the measurement of angle KNM is equal to 180 degrees. Now I'm going to subtract 75 degrees from both sides. So that's going to cancel out. So I have just K and M all by itself. What is 180 minus 75? 105. That is the whole angle right here. This whole thing put together is 105 degrees, but I don't want that whole angle. I just want this little piece of it here. Well, how much of this whole big angle, KNM, is the little part that I want? Half of it. The measurement of angle KNP is half the measurement of angle KNM. And we just found out how big KNM is, didn't we? How big's KNM? 105. So KNP is half of 105 degrees. And what is half of 105? How much? Close. That'd be half of 110, huh? 52.5. 52.5 degrees. Nice work on that one. All right. Let's flip over to page 8. We're going to look at problem number 6. You need to put your phone away. All right, first thing they tell me here is that RHOM is a rhombus. So I'm going to mark this one all up just like we did with the last one. The four sides of a rhombus are all congruent. So RH, RM, OM, and OH are all congruent. What do I know about my diagonals? They bisect each other. So HX is congruent to MX, and RX is congruent to OX. What is happening right here where the two diagonals are crossing? Makes 4 right angles. They have one of them marked for us. We can go ahead and mark the other right angles here. And then last thing I want to know is about these little half angles where they're being bisected. They would be congruent to each other, right? So RHX is congruent to MRX, or sorry, HRX is congruent to MRX. HOX is congruent to those two, as well as MOX. RHX is congruent to OHX, is congruent to RMX, is congruent to OMX. All right, we have all of our congruences marked and we have our right angles marked. Let's see what kind of information they give us to add to the picture. It says that the diagonal HM is 12. Well, if this diagonal right here is 12, how big is this much right here? 6. So I have 6 and 6 to add up to 12. says RO is 16. Here's RO. It says that whole thing is 16. So how big is this? 8. This side is 8. This side is 8, so that it adds up to 16. And then there's one other thing that they tell me. What other information do they give me? MOX, angle MOX is 19 degrees. MOX. So this right here is 19 degrees. First thing they want me to find is the length of HO. Now, looking at this carefully, I know that those diagonals, because they are perpendicular in the center where they cross each other, it's cutting my rhombus into 4 right triangles. Let's look at the right triangle where HO is. Right here. Do I know 2 of the sides of that right triangle there? And what can I use to find missing sides of right triangles? I can use Pythagorean theorem. A squared plus B squared equals C squared. Which part of the right triangle are we looking for? A, B, or C? C. This is the hypotenuse that we're looking for. It is across from that right angle. So I'm going to put HO in the place of C. And in the place of A and B, we're going to put 6 and 8. It doesn't matter which one goes in the place of which. So I'm going to have 6 squared plus 8 squared equals HO squared. What is 6 squared? 36. What about 8 squared? So 36 plus 64 equals HO squared. What is 36 plus 64? 100. So 100 is equal to HO squared. Where do I go from here? Square root. So we're going to square root the left and square root the right, because if you do it to one side, you do it to the other. On the right, the squared and the square root cancel each other out. What is the square root of 100? 10. So 10 is equal to HO. I'm going to add that to my picture. Well, if HO is 10, how big is RH? 10. RM? 10. MO? 10. I asked that because they want me to find the perimeter of RHOM. What would the perimeter of this shape be? 40. 10 plus 10 plus 10 plus 10 gives me a perimeter of 40. All right, now we're going to look for some angles. I want the measurement of angle HOX. HOX, this angle right here. How big is this angle? 19. It is congruent to MOX. So this would be 19 degrees. MXR. MXR. How big is that angle? 90 degrees. And last but not least, RHX. So R up to H and down to X. We're looking for this angle right here. Well, I'm going to look at this triangle right here, because I know one of the angles in it is a 90-degree angle right down here, right? And do we know how big HRX is, this angle right here. How big is it? 19 degrees. So now I can use my triangle sum theorem to find out RHX. So the measurement of angle RHX plus the measurement of angle HRX plus the measurement of angle RXH is equal to 180 degrees. RHX is what we're looking for, so I'm going to leave that as just RHX. How big is HRX again? 19 degrees. And what about RXH? 90. So now I want to combine my 19 and my 90 together. What is 19 plus 90? 109. So the measurement of angle RHX plus 109 degrees equals 180 degrees. I'm going to subtract 109 from both sides. What is 180 minus 109? 71. So RHX is 71 degrees. Very nice work. Let's talk about squares for a little bit. Squares are a special type of parallelogram because they meet all the qualifications of a rhombus, so I can mark it up exactly like I marked up this rhombus. But there's two things about a square that make it special, that make it different from a rhombus. Talk to me about the corners of a square. All right angles. So it tells me here that this shape is a square, EFGH. So the corners are all right angles. The sides are all congruent, EH, EF, GF, and HG. What do we know about the diagonals of a square? They bisect each other, and what else? Because this is really special about squares. It's the same thing for a rectangle, too. They're congruent. So EJ is congruent to FJ, is congruent to HJ, is congruent to GJ. So my diagonals are congruent to each other, and they bisect each other. What's happening here where the two diagonals cross each other? They're 90 degrees. It's forming 4 right angles in here. And then last thing I want to ask about, these angles up here in the corners, the right angles in the corners, they have these diagonals coming into them, right? And this is a special kind of rhombus. So what would be true about these two pieces? They're congruent. Specifically, they're how big? Because I know it's a right angle that's being cut in half. 45 degrees. Because 45 plus 45 gives me 90. Same thing is true for every single corner. 45, 45. All right, let's see what else they gave us to work with. It says that FJ is 19. This distance right here is 19. What do they want me to find? FH. Well, how can I find FH if I know that FJ is 19? We multiply it by 2, yes. FH is equal to 2 FJs. And FJ is 19, so I'm going to do 2 times 19, which would give me what? 38. Number 8 is worded a little bit strangely, so let's read through that together. It says, in rhombus, PQRS. PQ is 4x plus 3. QR is 41. And the measurement of angle PQT is 2x plus 4y. What must be the values of x and y so that PQRS is a square? So I'm going to solve this as if it was a square. I know for a fact it's a rhombus. I'm going to apply all of the properties of a square to this figure, and then we're going to figure out what x and y would have to be to make that true. So I know that all four sides of the square are congruent to each other. I know that all four corners of the square are right angles. I know that where the diagonals are crossing each other, it's forming four right angles. I know that the diagonals are bisecting each other and they're congruent. And I know that where the diagonals are coming into the corners of the square, it's cutting it into 45-degree angles. I could write it on all of them, but I'm afraid that's going to mess up, like I'm going to have way too much going on here. All right, it says that PQ is 4x plus 3. So across the top, 4x plus 3. QR is 41. That's the right-hand side. And angle PQT is 2x plus 4y. PQT, this angle right here, is 2x plus 4y degrees. That expression has both an x and a y in it, so I'm not going to be able to solve that first. I have to know either what x is or what y is. Do I have enough information to figure out what x is? Yes. What can I use to find x? 4x plus 3 and 41. And what can I do with those two? Set them equal, and I can do that because why? The sides are congruent, yes. PQ is congruent to QR. So that means that PQ is equal to QR. The lengths are the same. So I have 4x plus 3 is equal to 41. And then I want to solve this for x. So I'm going to start by subtracting 3 from both sides. What is 41 minus 3? 38. And then to find x, I'm going to need to divide both sides by 4. What is 38 divided by 4? How much? 9.5. So x is 9.5. Now we need to find y. It said that PQT was 2x plus 4y degrees, but I know exactly how many degrees that angle is. How many degrees is PQT? 45 degrees. The measurement of angle PQT is equal to 45 degrees. And we have this expression for PQT, 2x plus 4y. That's going to be equal to 45 degrees. We just found out that x is how big? 9.5. So 2 times 9.5 plus 4y equals 45. What is 2 times 9.5? 19. So I have 19 plus 4y equals 45. We want to get the y by itself, so I'm going to subtract 19 from both sides. What is 45 minus 19? 26. And then we divide both sides by 4 to get the y all by itself. What is 26 divided by 4? 6.5. So y is 6.5. If x is 9.5 and y is 6.5, then this shape would have to be a square because all four sides would be congruent and my angles, my little half angles, are 45 degrees. All right, we got 2 more problems to go and then we are done. Let's look at number 9 next. What does it tell me about the shape in number 9? That is a square. So I'm going to go ahead and mark this up with all the information that we know about squares. What do we know about the 4 sides in squares? They're congruent. What do we know about the 4 corners in squares? They're right angles. So A, B, C, and D are right angles. What do we know about where these diagonals are crossing in the center? They also make right angles. So I have 4 more right angles in here. My diagonals bisect each other and they're congruent. So AE is congruent to CE, is congruent to DE, is congruent to BE. And then what do I know about these little pieces here? They equal 45. So 45 degrees, 45 degrees, 45 degrees, 45 degrees. I'm not going to draw any more of them in there. That's plenty. I want the measure, for the first question, of angle AEB. How big is that angle right there in the center? 90 degrees. So AEB is 90 degrees. What about angle BAD? This angle here. No. 90 degrees again. The corners of the square are 90 degrees, and where the diagonals cross is also 90 degrees. All right, what about angle DCA? This angle right down here. How big is that angle? 45 degrees. All right, leaving angles behind now and looking at sides. How big is side AD? 22. Tells me on the bottom of the square that DC is 22, so that means that AD is 22. AB would be 22, and BC is also 22. Next, we want to find EB, this segment right here. So I'm going to look at this triangle here. I'm actually going to go ahead and redraw it off to the side. What type of a triangle is that? What'd you say? It is isosceles. There's one more word that goes with that because it's special. It's a right isosceles, because remember we have a right angle right here, and these angles are each 45 degrees. So we have a right isosceles triangle, also known as a 45, 45, 90 triangle. That 22 that we know up at the top, is that a leg or a hypotenuse? That is a hypotenuse. And if you guys remember, our rule on a 45, 45, 90 triangle is that the hypotenuse is equal to the leg length times the square root of 2. We were asked to find BE, which is one of the legs, and we have the hypotenuse. The hypotenuse is 22, so I have 22 equals BE times the square root of 2. I'm going to divide both sides by the square root of 2 to get BE all by itself. And remember, I can't leave a radical on the bottom, so I need to multiply the top and the bottom by square root of 2. So I'm going to swing my work around here because I ran out of room. So I have 22 square root of 2 in my numerator On the bottom, I have square root of 2 times itself, so that would be the square root of 2 squared. That would be equal to BE. What is the square root of 2 squared? Square root of 2 squared. 2, because remember the squared and the square root cancel each other out. So I have 22 square root of 2 over 2 equals BE. And then the last thing I have to see is whether or not this can simplify. Can 2 go into 22? How many times? 11. So 11 square root of 2 is equal to BE. All right, last thing they asked me to find on this is the length of segment BD, which is that whole diagonal. Well, how much of that whole thing is BE? Half. So I want to take 11 square root of 2, and we're going to multiply that by 2. That 2 on the outside is not underneath a radical, so I can only multiply it to other things that are not under the radical. What is 11 times 2? 22. So I have 22 square root of 2 for the length of DB. All right, very last problem. Given the diagonals of a rhombus are 18 meters and 80 meters long, find the perimeter. So I'm going to do my best to draw a rhombus here. All right, there's my rhombus, and I'm going to go ahead and draw in those diagonals. The shorter one is 18 meters long. So how big is this much of it? How big is this? If the whole diagonal is 18 meters. 9 meters. So 9 meters and 9 meters. The other diagonal is 80 meters long, so how big is this much of it? 40. So I have 40 meters and 40 meters. What do we know is happening right here where the diagonals are crossing? Right angles. And we are supposed to find the perimeter here. Let's look at just one of these triangles. I have a right triangle, and I want the outside piece. What can I use to find that? Pythagorean theorem. A squared plus b squared equals c squared. We're looking for c. So I would have 9 squared plus 40 squared is equal to c squared. 9 squared is 81 and 40 squared is 1,600. Can somebody find the square root of 1681 for me? $41. So that means this unknown side is 41 meters. How would I find the perimeter now? $41 times 4. What is 41 times 4? $164 meters is our perimeter. Very nice work on the notes today, guys. Homework number 5 is due tomorrow. Please come in with that homework completed so that we can grade and correct it and talk about our last 2 shapes, kites and trapezoids tomorrow.